Alright guys, so we're going to find the area of circles and sectors right now. First off, you're going to want to make sure you note that the area of a circle is pi times r squared. R represents the radius of the circle. So we want to jump in and do some practice problems. If I know the radius of a circle is 5 centimeters, well then the area then can be given by simply area equals 5 squared times pi, which can be simplified to be 25 pi centimeters squared. Notice in this time we're leaving our answers in exact terms, or we say it as in terms of pi. Meaning, I actually don't want to type pi into my calculator, and I definitely don't want to use the decimal approximation of 3.14. Now, there are applications for when we want to do that, but only use 3.14 as an estimation if you're asked to do so. Now, if we had the diameter for our given information, remember that area is pi times r squared. So first thing we're going to have to do is figure out what the radius is. Well, the radius would be 5.75. Simply divide your diameter by 2 to determine your radius. So we did pi times r squared, we would get 33.0625 pi inches squared. Okay? So that's our first part. I'm trying to do this kind of covering the answer technique, kind of save us some time here to have me write everything out. By the way, by all means, feel free, guys, to pause the video at any point before I reveal the answer. Give yourself some time to work it out on your own. So we have this example here about Jane making this poster. Now, in this example, they actually tell us the area. She wants the area to be as close to 16 square inches as possible. So we can actually write a little formula here, try to cover up both parts of the answer. 16 equals pi r squared, and we're going to solve for r. Now in this case they did tell us to use 3.14 for pi, so we can go ahead and use 3.14 for pi. What I did is I put in 3.14 for pi and then divided both sides by 3.14. In doing that, we would get 5.0955. Now that's a rounded answer as well, but eventually I'm going to round to the nearest whole inch anyway, so 4 decimals is more than enough for now. I need to take the square root of each side in order to determine that the radius would be 2.2 and change, but we would round our answer to 2 because our answer says what whole inch radius would it be. Okay? Now, we're going to move on to the area of sectors. All right, so let me reset our pages, and we'll get the area of sectors displayed for you guys. All right, so the area of a sector. First, we want to understand what a sector is. A sector is just a portion of a circle. So when we calculate the area of a sector, we're finding the section of a circle, of what it represents. The formula for area of a sector is right in the center text box. The formula is m over 360 times the area of this whole circle. M represents the central angle. So in this first example, m is 120, and in my next example, m is 270. So if we want to find the area of each sector, what I'm really going to calculate is area equals 120 over 360 times 9 squared pi. This is the area of a circle, radius squared times pi. To simplify our answer, we can then do the calculation and get 27 pi centimeters squared. Likewise, repeating that process with this next circle, again, feel free to pause it if you want to give yourself time to try the problem on your own. We would put in 270 over 360 times 2 squared times pi and get our final answer of 3 pi centimeters squared. Now, we want to check out maybe some more complex examples, like on our next page. So on our next page, we have some more tricky examples with these kind of weird-looking shapes here. Now, we almost treat this like a compound figure. One thing I went ahead and already drew in is I split this last portion into a triangle and this rectangle. This is a 7, and this is a 4. We know that this side length has to be a total of 8 to match this side, And this is 13, this whole size 20, that means the bottom of that triangle is 7. Now, in order to find the total area of this blue looking shape we need to find the area of each component. So to find the area of each component, try your hand, maybe pause it, see if you can calculate the area of each component, and then I'll reveal the setup for this problem. Here's how we find the area of each component. But so I don't want to reveal that answer yet. This is the area of the semicircle. I'm going from left to right. The area of the semicircle, the area of the rectangle, the area of the triangle, and the area of the semicircle, again, on the right-hand side. We would actually be able to calculate each one of these individually and then add them together for the total area. When we calculate them individually and calculate the entire area, we would get 118 plus 16 pi. Again, these are not like terms, so I cannot add them. You can think of pi like an x term, so it cannot be combined with my constant of 118. In a very similar fashion, we can solve the area of this rectangle and semicircle construct. We would find the area of the rectangle and just add it to the area of the semicircle. I want to show you one different way of writing the area of a semicircle. We can write it like this. The area of the rectangle is 120. 6 times 20 is 120. The area of the semicircle is the radius squared. Notice the entire diameter is 20. That means the radius is 10. Radius squared times pi, all divided by 2. So we can multiply by half or divide by 2. Those are equivalent. Adding these together, we would get 120 plus 50 pi. And we'll put in square centimeters just so we have the proper units. I'll throw that back on the other answer also. Now, this last section I want to do as a group. So, if we want to find the area of these shaded regions, right? Concentric circles, or circles within a circle, or these shaded region problems, our goal is to take the area of the whole figure first. Then we subtract the area of the non-shaded region. So, how do we do that? The area of the whole figure would be, it's a circle, so it's pi r squared. Well, r is 3, because it's the entire radius. So the area is 3 squared times pi, or 9 pi. Now we're going to subtract by the area of the non-shaded region, or the area of this white circle on the inside. Well, that's 2 squared times pi. 2 squared because the radius of the inner circle is 2. 2 squared is 4. That means my area of the shaded region is 5 pi square centimeters. Again, the entire area minus that white area. On this last portion, we have the area where we have a circle, but we also have a triangle. So we're going to have to subtract the area of the circle by the area of the triangle. In order to do so, I'm going to need to find some of these missing side lengths. Well, there's a 30, 60, 90 triangle. Now, I posted a video on how to review 30, 60, 90 triangles. You might want to go back and check those out. The side lengths that we can fill in are 6, and this entire side length is 12. Meaning that my radius is only this portion right here, which is 6. Okay? So the area of the circle would be 36 pi. Again, take the radius squared times pi. We're going to subtract the area of the triangle, which is 1/2 times the base times the height. This would give us 36 pi minus 18 radical 3. These are not like terms, so my final answer is simply 36 pi minus 18 radical 3. Again, you might want to go back and check out those 30, 60, 90 triangles reviewed. All right, guys. Have a great weekend and good luck on the practice. Message me if you need any help. Take care.